This is Tim Hegarty with the virtual training company C++ Fundamentals. We are now going to take a little deeper look at the fundamental of class member access, and this gives us the term encapsulation. Encapsulation allows us to have functions or methods, they're called in classes, and data members of the classes totally enclosed within the class unless we specify otherwise. Whenever we create a brand new class and don't say otherwise, the members, methods, data, everything that's in there is private. That's by default. The class members can then only be used by the class member functions. The methods that are built into the class can only get to that data that's part of inside the class, or classes specified as friends, and we'll take a look at that in a little while in a different video. We can specify public access. Public access means that any other function can get to or call those class members and methods. It's totally open. Protected is kind of a combination. Protected access says that the class members can be used by the member functions of the same class and by any derived class member functions. So if we have a higher level class of car, let's say just a car, and then we derive a class below that of Ford, then the derived class could make use of things that are in the car class that are above it, that it has been derived from, but nobody else could get to it. So you kind of have a family tree going on here of classes when you have derived classes like that. Here, for example, is a simple my class being created. All of these members, X, Y, and Z, are private because we have not said otherwise. So only, and we don't have any here, we haven't defined any methods, but only methods of my class would be able to work with X, Y, and Z and store things in them. Gives a very tight black box, or encapsulates the data within the class. Now here we have used the public keyword in this class, and X is still private because it comes before the public access specifier. Y and Z, however, are now public, so any other function, anything else that wanted to get to myClass.y could get there and work with it. And then finally, here's the protected. We have int X is still private, int Y is now public, and we have the protected is Z. We can work with functions within my class, methods within my class can work with Z, and anything that is derived from my class can work with Z, but nothing else can get to it. So it's encapsulated along the lines of the family tree. And this is class member access, which implements the fundamental of data encapsulation within object-oriented programming.